Hi, my name is Andrey. I'm a principal engineer at Azure Database for PostgreSQL. My talk is about Azure AD authentication with flexible servers. If you use flexible servers or plan to try it out, this feature will help make your application connections more secure. It will save your time managing credentials and roles, so please check it out. Azure AD authentication with PostgreSQL Flexible Servers is an enterprise security feature we added to Flexible Servers offering recently. It simplifies credential management for your PostgreSQL deployments, and it also makes those more secure. A little bit about myself. I'm a principal engineer at Azure Database for PostgreSQL. I've been there for 3 years. Before that, I've been working on mostly application layers at Microsoft and Google. Outside of work, try to travel a lot with my family, and I'm also a home cooking enthusiast. So even when I travel, taking some home cooking equipment with me to enjoy both of those passions together. Our talk today would be of 4 major parts. I will start with giving a brief introduction of what is Azure Active Directory and how it works with Flexible Server. I will go through a simple Hello World example on how to connect to Flexible Server with Azure AD credentials. Then we will do similar things, but as an application would do, and go through a little more advanced application scenarios. And in final go through some other topics on this feature. So let's start with the intro. Azure Active Directory is an enterprise identity and access management solution. It implements industry standard protocols, Auth2, OpenID Connect, which you use every day authenticating anywhere on the web. It's different from just Active Directory, which is an on-premise solution using Kerberos protocol. Azure Active Directory supports multiple enterprise security features. It has many options for multi-factor authentication, and it allows the tenant administrators to configure precisely what are the users group, which applications which user can connect, and what is the level of security for each of those connection types. The management of that is done through Microsoft Graph, which is a unified API layer to manage user groups, applications, other security and authentication related objects. When works with the flexible server, Azure AD authentication, Azure AD takes over the credential exchange. When you usually connect to your PostgreSQL servers, you exchange the credentials with PostgreSQL, and that's where those credentials are validated. In case of Azure AD authentication, you start the connection with connecting to Azure Active Directory and exchanging the credentials with Azure Active Directory using the standard single sign-on form or application backend authentication protocols. Once the user is signed in according to the enterprise security setup, going through all second factors needed, it gets back the token. The token is it's a JWT token, which is a standard for OpenID Connect protocol, which is an encoded JSON document, which includes user identifier, application identifier, tenant identifier, expiration date, and expected audience, which is in this case Azure open source databases. It also includes the signature, which is all the information above, but signed with the Azure Active Directory private key. After getting the token, the application or a client sends this token to the flexible server, where we run an extension to validate that token. For validation, we use the public key of Azure Active Directory to validate the signature. Then we extract those pieces of metadata and validate them against the expectations set by the server administrator. If everything matches and token did not expire, then the authentication succeeds and the session can be started. The token is sent as a password, so we reuse password exchange in Postgres Fire protocol. Azure Active Directory is integrated throughout Azure. Anytime you open Portal, you are authenticated with Azure Active Directory. And whenever subscription you have, even if you have simple test subscription for your side project, you have or connected to an Azure Active Directory tenant. Here is a screenshot from the my user object from my personal test subscription. And when you have tenant, you can manage it. You can add more users, more groups, set up applications, configure how the authentication works. You can also use Azure Active Directory authentication with any Azure Active Directory setup, even the minimal free tier, and it also works with the lowest SKU available in Flexible Server, which is burstable vNMS. So the entry point for you to try this feature is reasonably inexpensive. Now let's jump into the Hello World example. For this example, let's pretend that we are building a simple expense application where we have user putting up their expenses, and then we may have supervisors who approve or reject those. Pretty simple, just data editing backed by PostgreSQL database. We'll start, and for this example, we will use a terminal with AZ-CLI installed. So we start with provisioning Postgres Flexible Server using AZ-CLI. I highlighted that we need to enable Azure Active Directory. We can also optionally disable password authentication, so we don't have to put a login and password for administrator. Once the server is provisioned, we can create our first Azure AD user, which will be Azure AD administrator. So they would be able to do some work on the server. In this example, I provide admin at expenses.app, which is for our application. Assume that it's our developer and admin for the first time, and that's their Azure Active Directory username. We also pass object ID and the user as the object type. I'll explain what is object ID and what user object types available a little further. Once we create the user, we can connect to that. First, we need to get the token from Azure Active Directory. Simple way to do this with CLI is using AZ account get access token with per resource type. Once we get that, will pop up your single sign-on authentication window. Once that is done, you will get back the response containing the token. Here I'm using JQ util to extract the token itself and export it as a PG password for pSQL to use. And as the last step, we connect with pSQL using our role name, and the password will be from the environment variable. That's very easy for the command line. If you are using the graphical tool like pgadmin, it's a little bit more work needed because you would need to get your token, copy the token, and put it in the password field. Once the session is established, it will not be terminated even when the token expires. However, if the token expired and you want to open a new session, you would need to acquire a new Azure AD token. Hope to see that eventually in the future, the more graphical tools will have a full integration with single sign-on flows built in there, so you won't need to copy the token, but we're not there yet. So now we've created the role. We can use the function, which we provide pgad auth list principals in order to look under the hood. That would return information of our first role, its name, principal type object ID, the tenant ID, which it is from the Azure AD tenant, and a couple of other fields. ISMFA, it allows you to require multi-factor claim requirement specifically for Postgres server. If it's not generally required in your tenant, then the database connection have to be more secure than the tenant in general. Is admin denotes if that particular user is Azure AD admin. Azure AD admin is similar to regular Azure PG admin, which you have on Flexible Server. It can do the same things like adding, setting up role inheritance almost without limitations. But it also can create Azure AD enabled roles, which non-Azure AD administrator cannot do. So far, we've created a user principal, role corresponding to user principal in the Azure Active Directory, which usually means that it's a person. Then the second major group of the connecting principals are service principals, which is the concept in Azure Active Directory, which combines a regular application clients from OAuth, OpenID protocols, and managed identities, which is an Azure resource type, which can be assigned to your virtual machines, Kubernetes clusters, and other resources, which simplify credential management and allows you to get token for that resources to connect to the other resources without the need to manage the application or client credentials. There is also groups, which can contain both users, service principals. It can also have other groups. For all principals, we store object ID. For users and groups, it's easy. You can open the Azure portal for this object and see the object ID there. For service principal, you need to use enterprise applications page in the portal to see object ID. Note that in Flexible Server, we do map one PostgreSQL role to one object ID from the Azure Active Directory. We can have multiple roles mapped to a single object ID, but there is no practical reasons to do it. Now, as we connect it as a user, we can look at how your applications and the backends would connect to PostgreSQL. Let's start with a simple example of connecting as a backend using the application credentials. The easiest way to do that is to use a managed identity, which manages application credentials on your behalf. For that, we start with provisioning a virtual machine. There is a little screenshot on how you do this via portal. You need to checkbox identity. Once it's provisioned, install pSQL and JQ to get the token manipulation and connect to the Postgres. For this example, I assume that the virtual machine name expenses-VM, and it's unique inside your Azure AD tenant. In order to create the role, then we get back to our pSQL as the Azure AD administrator, how we connected on the previous slides, and use a function pg-ad auth create principal, passing the server managed identity name, which is expenses-VM in this case, and the MFA and admin flags. Once that is done, you can query again pg-ad auth list principals in order to see that the second Azure AD role successfully added. In order to connect from our VM to our Postgres database, first, we should not forget to allow the VM to connect to the server at the first place. For this, you need to add a firewall rule on your Flexible Server, which can be done with the command here, az Postgres Flexible Server firewall rule create, using the VM IP as a start and then addresses. After that, we can connect with the terminal to our VM and start connecting. Start with using the URL to get the managed identity token. That is a special URL here, which is used to obtain managed identity tokens. And the resource type you use for flexible server is OSS, RDBMS, AD Database, Windows Net. Now we use curl in order to call our URL we just exported, get back the token, and use the same technique of JQ plus PG password to export it for pSQL to use. And the last step, we connect to the Postgres server using the managed identity name, which is the same as the role name in this case, as the user. That's it. So after that, we connected to our Postgres as the application would do. You don't need to manage any credentials here. Everything simple is straightforward and done by Azure and Azure Active Directory for you. Now you can do the same with the application development platform which you use. We have the most comprehensive support for the managed identity connection in Java, which is Spring Cloud Azure SDK. It has a feature passwordless connections, which does use managed identities and Azure AD authentication for the connections. In different other SDKs, which we have for .NET, Node.js, Python, and others, there is an easy way to get managed identity token. And for even more extended list of the technologies and languages, there are MSAL libraries which allow you to get the application tokens. You can go to azure.com/SDK for more information on SDKs available. In addition to the managed identities, you can use a regular application client secret or client certificate in order to authenticate as application, similarly to any other OAuth based identity providers. What we've done so far is we connected to the backend using application own identity, which is the easiest way to make your connection. But it requires, if you write the application where user can access the data, that approach would require you to handle access to different information on your application at your application layer. And all connections would be done under the backend's own identity. The alternative for user-facing applications would be using the delegated auth or user impersonation, where your application uses the user identity in order to connect to the PostgreSQL server. It allows you to utilize PostgreSQL row-level access control in order to manage which data particular users can see, which is specifically handy for the cases like our expenses application, where each user can see the records which they created, and maybe supervisors can only see records for the group they manage. That can be achieved by creating an individual user roles for each user in your PostgreSQL database, setting up row-level access, and Postgres will make sure that every user can only see and edit the data which belongs to them. In addition to that, it would also improve your audit, because if you say use logline prefix, then you stream your logs to Azure Log Analytics, and that all records in your logs, including the audit, will see what was the end user which created, edited, or deleted certain information in the database. In order to implement this solution, your application need to have some sort of single sign-on when the users connect to the application using their Azure Active Directory credentials. You're using the end user token alongside with the application's own credentials in order to get the delegated or on behalf of token from Azure Active Directory. Then, once this token is acquired, the application connects to the PostgreSQL using the end user Azure Active Directory username and the delegated token. In this case, the flexible server would interpret this connection as an end user connection and authenticate the end user. That setup, though, would not work with the managed identity, so you would need to manage the application credentials like certificates or secrets yourself. Now let's get to more advanced features we support with Azure AD authentication. The first one is group, logging as group members. In example so far, we've created individual roles in PostgreSQL Server for each individual user. The alternative can be is that you create a role for a group. Then your users or applications, they get tokens for themselves, but when they connect to the backend, they use the group name as the role. So they will be authenticated not as themselves, but as the group. Which has a certain advantages. It simplifies role management for you. You create the role and privileges in the database once, and once new users or applications are added to the Azure AD group, they immediately can access the database under the group role without need to add any configurations on the flexible server. On the other side, it complicates your audit a little bit because the role which you see on logline prefix would be the group role. And in order to extract the end user principal, you would need to join it with the login record, which has all the information. It also has some edge cases when you have a very sophisticated setup with multiple groups, have different privileges and different users, members of multiple groups. You may end up with the user needed to log in multiple times in order to get different privileges. What we've looked at so far was when we created the roles in PostgreSQL where names matched the Azure Active Directory principal names, which is an easy way to go, but it's not always enough. For example, when the names of groups or applications are not unique in the tenant, Flexible Server would not know how it can disambiguate between them. So you would need to provide the object ID and the object type when creating the role. Then the Flexible Server would validate that this object ID and type indeed exist in the tenant, and then do regular token validation, and the connection can go through. In order to create or update roles those way, can use a couple of functions. We provide pgad auth create principal with OID and pgad auth update principal with OID, which effectively where you provide the role name, whatever you want it to see, and then the object ID and type in the tenant. It allows you to disambiguate non-unique names in the tenant. It can also be used if the way you manage the Azure Active Directory results in long and non-manageable object names, and you want to shorten them and make more readable in the database. Or you can use it if you already have a sophisticated setup of users and roles in PostgreSQL, and you want to switch to Azure AD authentication without need to reconfigure the Postgres privileges. In this case, you would be able to remap the existing roles to the Azure AD principals using those functions. Now we can end with several other topics which our customers, users of this feature frequently ask, and I think worth mentioning here. The first one is throughput and performance. When you connect as users or service principals, you should not expect any degradation in either connection time or the amount of connections you can open over a period of time. If you connect with users but connect as a group roles, then there is a certain cases in which we would need to make the remote call to the MS Graph to validate the group membership. We try to avoid making those remote calls, cache the group membership for the Postgres postmaster lifecycle, but it's still possible that you would see maybe 100 millisecond connection time to do the group validation. We do support Azure AD authentication with built-in PG bouncer with flexible server. On the other side, if you set up your own PG bouncer deployment using the community code, you would not be able to use Azure AD authentication at this point in time. For the VNet deployment, so if your flexible server is deployed inside the Azure Virtual Network, you would need to configure your NSG rules, route tables, or firewalls to allow the flexible server to connect to Azure AD services. Otherwise, the feature would not work. If you want to use a cross-tenant scenarios, like user from one tenant connect to the database in the other tenant, you would need to have that user invited to the tenant where the PostgreSQL subscription is hosted. The true cross-tenant scenarios are not supported with Flexible Server at this time. All the objects connecting to Postgres database have to be from the same tenant as the PostgreSQL Server subscription. Yep, that's it for today demo presentation. There's some links which you may find helpful. Link to the slides where you can find the link where you can find more great topics from Citus Con. Link to the official documentation for Azure Database for Postgres Flexible Server AD authentication, and also a link to my LinkedIn page. Thank you so much, and hope to see more adoption on this feature, more of you using this to make your application more secure, and eventually more adoption of the identity providers into the Postgres security and authentication ecosystem. Thank you.